Hello everyone, I hope you're all doing well. In today's experiment, we're going to do the following experiment over here. Um, the experiment is how we're going to establish a local area network uh, using 4 PCs and 2 switches. The following experiment is different from the previous lessons in a way that we're using a switch, which is a layer 2 devices, which is a data link layer device, and it specifically knows each of the in devices IP MAC addresses, and whenever I try to transmit data, it just simply send it to that device specifically. So in order to finalize or conduct this experiment, we have to know some prerequisite knowledges. The cable types. There are basically 2 types of cable: copper straight through cable and copper crossover cable. If the devices are the same, then we have to use copper crossover cable. If the devices are different, we have to use copper straight through cable. So let's finalize the whole thing. In order to configure this experiment, we have to choose a switch. The following switch we are going to use is 2960, and in devices we're going to use 2 PC for this switch and 2 PC for this switch. Okay, so now we have to do the wiring part. Since we are going to connect these 2 switches together, we have to use copper crossover cable because they are the same devices. For the same devices, we always use the crossover cable. And we have to connect these device with these individual in devices such as PC. If you try to configure it, which type of cable we're going to use, obviously the copper straight through cable. Okay, let's try to configure it. That is being done and also done. Okay, and lastly this one and this one with this one. Okay, we can choose any of the port because it has like how many ports we have to see. It has like 24 of the port. We could choose any of it. Okay, it doesn't matter. So now we have to put the IP addressing manually. We can just simply do this. Okay, let me just do it more appropriately. 192.168 92.168.10.1. Okay, this tag has nothing to do with the actual IP addressing. You still have to do it manually on the PC. 168.10.2. So why we are choosing these IP addresses? Because we have conceptualized the whole network as a class C IP addresses, or this whole network is a local area network of class C. So each of the individual devices, the host network portion will be always the same. The host portion will be unique for every single PC. So this one would be 1, 2, this one would be 3 and 4, and so goes on. We have to just simply put in tag every single one: 192.168.10.3, and for the last one, 192.168.10.4. Okay, and the tag is being done. Now we have to manually configure each of the IP address. We have to choose the desktop, then IP configuration. In the IP address version, 192.168.10.1, 255. It's being set for the first one, and for the second one we have to do the same configuration. Yeah, okay. 192.168.10.2, it is also being set. And for the third one we have to do the same way, but the host version's address would be different. For this one, fast 3 network version is always the same, but the host version is always different. Yeah, okay, this is being set. And then finally the last one, desktop IP configuration. Okay, what is it? 192.168.10.4. 192.168.10.4. That is also being set. Okay, and we're ready to go. If we try to send a package from this PC to this PC, it will just simply seamlessly, flawlessly send it. Let's try to see it in real time. Okay, suppose we're going to send a package from this PC, first PC, to this one, and the package is been sent successfully. Let's try to do this with this PC to that one. It is also being successful. And let's try to do this with this PC to this PC. Okay, this is also being successful. So if we do the real-time simulation, we'll see the fundamental difference from the hub, that the package is only being sent the following receiver that we intend to send. None of other devices will not receive it because we are using a switch rather than hub. Hub is not a intelligent devices, it was a dumb devices, but the switch is more likely intelligent devices. It exactly knows whose device we're selecting to send the packages. So let's try to simulate it in the real time. The package is being sent. It won't send any other devices because it knows specifically which device we need to send the package. In our case, it was this one. It will just send this one. The package is being sent. Now it will send the acknowledgement back to the sender. So the whole simulation was seamlessly flawless and our experiment was done, but we still haven't completed yet. If we try to configure or simulate the same thing, for example, we try to send packages from this switch to this switch, it wouldn't be successful because we haven't functionally set up the port yet. So we have to do that. So first of all, we have to select the switch, then go to the command line interfaces and specifically set these following commands. So we can just simply copy paste it from here. There are the commands. Okay, these are the commands that I'm going to use for the switch one. Okay. Okay, let's choose the switch and also just simply paste it over here. Okay, so we renamed this switch as switch 1. That's why it is being shown like this. And we have to do the same thing to this switch 2. We have to choose the command line interface, then go to their command line prompt and choose the following command for the switch 2. So we have to enable it, configure the terminal, and host name would be whatever we sent it. This was one of my students' name. I'm going to try to show her the way it is being done. So I renamed that switch name into this. Now we have to just simply copy it and paste it over there. Yeah. So just simply paste it. Okay. The router is being reconfigured with these following name. Sorry, that was switch. Okay. So now let's try to simulate the following package if it is going to be sent or not. This one to this one. It is also in progress. In the first case scenario, it will be unsuccessful. It takes some times. Eventually, we'll reach in that manner. Let's try to see it why it's not being successful. Okay, finally we have reached to the successful message. So our whole experiment is being done, and we can finally conclude that the whole local area network is being established seamlessly and flawlessly. And thanks for your time and patience.